Remember that electron transport chain? Okay. This is the way that the majority of the ATPs are produced. ATPs, energy of the cell, energy of the body. Okay. We need oxygen. Look at this. Where we need it. The final electron acceptor. That's where we need it. We don't need oxygen anywhere else. Have you ever thought about that? The final electron acceptor for the production of the ATPs for the energy of the cell or energy of the body. It's kind of mind-blowing if you think about it. Our waste from that process is CO2. We give off CO2 while making the ATP. It can be toxic to us if we don't get it out of our systems. So we have to get rid of it, and the plants get to use it. CO2, when the cell makes CO2 and it gives off the CO2, what it's going to do, it's going to combine with the water in the plasma of the blood. Anytime CO2 combines with water, you get carbonic acid. Do you happen to know any other way that we're exposed, or a very common way that we have carbonic acid? I don't see anybody in here with one. Soda. Ta-da! Okay? The sodas, think about it. If you go to the machine where you get the sodas, okay? What is it usually, what kind of gas do they usually have hooked up to the tanks? CO2. So that it can go into it, make it all fizzy bubbly, bubbly fizzy. How did he say it in, what was the movie that he played in? Zohan? Fizzy bubbly. Okay? And it makes it fizzy bubbly for that drink, and it's carbonic acid. So that lets you know it's a weak acid, because we take it in. Okay? It's a soda. It's a weak acid. It's still an acid though. So when CO2 is given off by the cells of the body, the blood's going to have to buffer that. And one of the cool things that happens in the blood, we're going to have those bicarbonate ions, and it's going to grab to those H pluses and buffer them until we get back to the lungs so that we can breathe off the CO2. Isn't that kind of cool? Y'all never tell me yes. Thank you. So now, if we think about all these products, all this chemistry, one of the things that we tend to think of as being light is organic, because organic is going to be carbon-based. When we talk about something having carbon, for the most part, when we think about the carbon atom on the periodic table, carbon is number 6 on the periodic table. So in the structure of carbon, where I've got my nucleus, I've got my first shell, and it holds 2 electrons. How many do I have left over? 4. So in that second shell, I've got 4 electrons. Is carbon happy? Not by any stretch of the imagination. okay? One of the elements that carbon binds to readily is hydrogen. Because how many electrons does hydrogen have? 1. So, in this example, I could bind to 4 hydrogens, and that would give me how many electrons in my outer shell? 8. Because carbon has this structure where there are the 4 electrons, and it readily combines with hydrogen, another element that it readily combines with is oxygen. When you put carbon, hydrogen, and oxygen together, when you put carbon to hydrogen together, the bond that forms contains tremendous energy. Now, sugars, carbs. What's our thought when we hear the term sugar? Well, yeah, but they're so good. They're good at being bad. Why do we say, when you hear sugar, what do you think about? What kind of foods? Cakes, cookies. My favorite, donuts. Ice cream.
That's dairy.
Now, sugars. What else might fall under what we term a carbohydrate?
Bread.
Breads,
Starches.
pastas, what we know as our starches. Gonna look at those in a minute, because guess what? They have tremendous amounts of carbon to hydrogen bonds. Therefore, tremendous energy. You want your body to get energy first from sugars. The second way that you want your body to get energy is from lipids. The lipids in our body, now I'm not talking about, fats that we're going to be taking in that are associated with something like our triglycerides, okay? No, I'm talking about energy that has been stored, for the most part, in our fat cells, or stored. Now let's keep that one, okay? Let's keep the one that's stored in our fat cells. So we want our body to get energy first from the carbs, second from the lipids. The last place that we want our body to get energy from is proteins. If your body is having to break down proteins to get energy, things are severely wrong in your body. All right? Don't say it doesn't happen, because it does. All right? But note, my carbs, my lipids, my proteins, what are you seeing in common in all three?
Carbon, hydrogen, and oxygen.
Carbon, hydrogen, oxygen. This means that the bonds located in these molecules have very high energy. Nucleic acids, this is our DNA. Your body will not break that down for energy. However, it is still a combination of carbon, hydrogen, oxygen. We have some phosphorus, some nitrogen, but it's making up your genetic material. It's housed, of course, in the nucleus, but what is something that your DNA has to do? Huh? What?
Change and grow.
Replicate.
Replicate, copy, change. It has to do that. So it has high energy bonds. Okay? When we look at what takes place, this R that you see listed here, that's always letting you know that there is a chain of carbons to hydrogens. That chain could be one carbon to carbon with hydrogens around it, or it could be a bunch of carbons, carbon, 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 and hydrogens around it, okay? But when we think about the functional groups, their functional groups change. For example, with the amine group, think of your amino acids, all right? They've got some nitrogen, hydrogens. If we look at, let's see, phosphates, which are going to be very important. Phosphates have P's and O's, all right? So basically what begins to take place is we're going to find that these molecules important to the body have chains of carbons, hydrogens around them, and then they have what we call different functional groups. And they have the ability to make these molecules that we're needing for life. So let's think about the one that I just seem to love the most, our sugars. Did you know that we have simple sugars and complex sugars? All right. How, Greg? Like you said, yeah, you've heard that we've got simple and complex. Okay. How have we heard that? Maybe in our foodstuffs. Maybe in the way that they kind of like advertise them to us. Okay. When we talk about simple sugars, glucose, fructose, galactose, they have one carbon ring. Now, what that tells me, think about this structure right here. Glucose. What's formula for that? C6H12O6. This tells me I've got 6 carbons. The way that we look at that structurally, it comes to us in a ring. For every point in the ring, that tells us that it's a carbon. I've got 12 hydrogens, and then I've got 6 oxygens. The structure, if I were to come look at glucose, 1, 2, 3, 4, 5, 6. If I were to count my H's, I would have 12, and if I were to count my O's, I would have 6. Glucose. The simplest sugar the body can use. It is